Swayam Prabha. Digital India. Educated India.
In this lesson, we will consider Y parameters which correspond to one particular choice of dependent and independent variables. Let us consider a linear network. Again, this means that there are no independent sources inside, but there can be dependent sources and linear resistors. This is port 1, this is port 2, and let us think of voltages being applied to these ports. V1 is applied this way, V2 is applied that way, and so we will have V1 across this and V2 across this, and we will have I1 here and I2 there. Again, these directions are conventions for defining the variables. Okay, the actual current may be anything depending on the insides of the circuit. Okay. Now, as we know, because this is a linear circuit, every branch voltage and current inside will be a linear combination of the independent sources applied, which are V1 and V2. So, I1 and I2 will also be linear combinations of V1 and V2. So, I1 will be something times V1 plus something else times V2. Now, clearly, to have dimensional consistency, these quantities here must have dimensions of conductances. Okay. In fact, this is the reason it is called Y parameters. We know that G is the letter used to denote conductances, but for frequency dependent circuits, there is a generalized form of conductance known as admittance, which is also the ratio of current to voltage, and that happens to be denoted by letter Y. Okay. So, these parameters which have these conductances as the proportionality constants in the linear combination are called Y parameters. Okay. For now, it is just a name for us. These are called Y parameters, and these Y parameters have dimensions of conductances. And similarly, the current I2 will be a linear combination of V1 and V2, and these constants again have dimensions of conductances. Okay. Now, these four parameters together, Y11, Y12, Y21, Y22, these are the Y parameters of the two port. Okay. Now, this relationship can also be expressed more compactly if we write the two currents as a vector of length 2, and we have Y11, Y12, Y21, Y22 arranged as a matrix times the vector of voltages V1, V2. Okay. So, I1 is Y11 times V1 plus Y12 times V2, I2 is Y21 times V1 plus Y22 times V2. Okay. So, this matrix here is many times called the Y matrix of the two port network. Okay. So, the Y matrix consists of 4 parameters, because we have 2 dependent variables and 2 independent variables. There are 4 parameters relating the currents to voltages. Okay. And these subscripts here. Okay. So, let us take Y12. So, the first subscript denotes the effect, meaning I1. I1 is Y12 times V2. Okay. So, what is Y12 times V2? It's the contribution of V2 to I1. Okay. So, I1 is the effect, V2 is the cause. So, the first subscript denotes which the effect is, and the second one denotes which the cause is. Or in other words, you can think of this as the input and this as the output. Okay. So, V2 gets scaled by Y12 to give you I1. Okay. So, that is the meaning of the subscript, and you can see that for the rest of them it is the same way. V2 gets scaled by Y22 to give you I2 and so on. Okay. So, that is the definition of Y parameters. Now, so far we have not done anything special. Okay. So, we knew that I1 and I2 would be linear combinations of V1 and V2, and that is what we have expressed, and there is a standard way of putting down these things, and that is what I have shown here. Okay. Just to make an analogy with one port, if you have a single port and you think of V as the cause, let us say V1, there is only one port. So, V1 as the cause and I1 as the effect. We know that I1 is some conductance times V1. Okay. What we have is exactly the same. We call this something else, we call it Y11 times V1. In case of a one port circuit or one port network, we have only one parameter. In case of a two port network, we have 4 parameters, and similarly you can imagine that in case of a 3 port network, we will have 9 parameters, because we will have 3 voltages and 3 currents and so on. Okay. So, if you have an n port network, you will have n square parameters describing the relationship between n voltages and n currents. Okay. Now, let us consider this once again. We also need to figure out how to measure these parameters. Okay. Meaning, in this case, when we had a one port, we know how to measure it. We apply the voltage and find the current. Okay. And the ratio of the current to voltage, this is the single Y parameter that is there. I can call this conductance as this Y parameter Y11. There is only one parameter in case of a one port. So, how do you do this? You apply V1, measure I1, and calculate the ratio I1 by V1. Okay. So, that is how we measure this parameter. What do we do in case of a 2 port? We have 4 parameters. So, that means that we need 4 measurements, and a convenient way of doing it is, let us say we want to measure Y11. Y11 appears in this first equation. Okay. The easiest way is to set V2 to 0, so that the second term disappears completely, and we have I1 equals Y11 times V1, and from that we can measure Y11. Okay. Set V2 to 0, apply V1 and measure I1. Because we set V2 to 0, I1 will simply be Y11 times V1. Okay. This is with V2 equal to 0. So, Y11 is nothing but I1 divided by V1 when V2 is set to 0. Okay. In other words, what is the meaning of setting V2 to 0? We short circuit the second port. Okay. So, you short the second port and essentially measure the conductance looking into the first port. Okay, because when you short circuit the second port, this whole thing we just have these two terminals to play with. We apply a voltage and find the current going there, take the ratio of current to voltage. So, this is nothing but conductance at port 1 when port 2 is shorted. Okay. So, that is how you measure Y11. So, we can continue this for other 3 parameters. If you want to measure Y12, what do? You set V1 to 0. The idea is the same. I1 is Y11 V1 plus Y12 V2. So, if you set V1 to 0, this term disappears and you will have only the term containing Y12. Okay. Then you apply V2 and measure I1. Okay. Meaning we have ports 1 and 2. This is V2. We short circuit port 1, that is the meaning of setting V1 to 0. Okay. And we apply V2 and measure I1. Okay. That is, we measure the current in port 1 while applying a voltage to port 2. Okay. And you can compute Y12 as I1 by V2 with V1 set to 0, which means port 1 shorted. Okay. So, unlike in the case of conductance, you are measuring the current in port 1, whereas the voltage is applied on port 2. Okay. Such a measurement, it is known as a transconductance measurement. That is, you apply a voltage here and measure the current elsewhere. If you apply the voltage at a port and measure the current at the same port, you will be measuring the conductance. If you apply a voltage at some port, measure the current at some other port, you will be measuring the transconductance. Okay. So, this can also be called transconductance from port 2 to port 1. That is, the cause, the stimulus is on port 2 and the effect or the response is on port 1. Okay. Now, we can see that by obvious extension, we can measure the other 2 parameters as well. We can measure Y21. I2 is Y21 V1 plus Y22 V2. To retain only the term containing Y21, we set V2 to 0. So, set V2 equal to 0, apply V1 and measure I2. Y21 will be the ratio of I2 by V1 with V2 being 0. Okay. And if I draw the circuit for it, I apply V1 to the first port, I short circuit the second port and I measure the current I2. Okay. So, I am measuring the transconductance from port 1 to port 2. With port 2 short circuited. Okay. And finally, to measure Y22, I2 is Y21 V1 plus Y22 V2. and to measure Y22, we set V1 equal to 0, so that term goes away, and we apply V2, measure I2 after setting V1 to 0 and calculate Y22 as the ratio of I2 by V2 with V1 being 0. And what is this ratio of I2 by V2? We short circuit port 1 and we apply V2 here and I2 goes in there. Okay. So, essentially we are measuring the conductance looking into port 2 with port 1 short circuited. Okay. So, this is the conductance at port 2 with port 1 shorted. Okay. So, this is how we would go about evaluating the 4 parameters. So, if you are given a circuit and you will see worked out examples later, what you have to do to measure these 4 parameters is to make 4 measurements. The most convenient way to do that is to short one of the ports and make measurements on the 2 ports, then short the other port and make measurements on the 2 ports. So, that will give you 4 parameters. Now, to be sure, there are other ways of doing it. You simply take 4 different combinations of V1 and V2 and measure currents I1 and I2 for these combinations. You will get 4 different equations, and from that you can solve for the 4 parameters. But this is the most convenient way of computing the 4 parameters. Okay. Now, because the measurement of Y parameters involves shorting of the ports, Y parameters are also known as short circuit parameters. Okay. So, to summarize, Y11 is I1 by V1. Remember, the second subscript goes here and the first one goes over there. Okay. With V2 equal to 0, meaning port 2 is shorted. Okay. And Y12 is I1 by V2 with V1 equal to 0 or port 1 shorted. Y21 is I2 by V1 with V2 equal to 0. So, that is port 2 shorted. And finally, Y22 is I2 by V2 with V1 equal to 0, port 1 shorted. So, what you can do is, you short port 2, that is you set V2 equal to 0, apply a voltage V1, then you can measure I1 to get Y11, I2 to get Y21. Then you remove the short from port 2 and then short port 1 instead, okay, and apply V2 to port 2, then you measure I1 to get Y12 and I2 to get Y22. Okay. Now, these two Y11 and Y22 are conductances. Of course, under a specific condition. It is the conductance looking into the circuit with the other port shorted, and this Y21 and Y12 are transconductances. That is, they are ratios of current to voltages, but not on the same port. The current is at some port and the voltage is at some other port. Okay.